Today I'm going to talk to you about exact values in trigonometry. So let's just talk about the isosceles triangle first of all. If I want to draw a isosceles triangle and use trigonometry, I need to have a right angle. And that means that these angles here would be 45 degrees each because of the sum of the number of angles in a triangle. So having a look at this, if I'm going to work out, well what's sine of 45, what's cos of 45 and what's tan of 45 in exact values, I need to put some measurements on this triangle. Well, because we've been using the unit circle, I could use any isosceles triangle as long as it follows the fact that it's got to have two sides the same. So let's go with the smallest side. Let's go with a unit triangle of 1 unit each here. Now I'm going to have to perform Pythagoras to work out the length of the hypotenuse. A squared plus b squared equals c squared. 1 squared plus 1 squared is 2. C squared must be root 2. Sorry, I've written c there, root 2. So hypotenuse is root 2. Let's perform some trigonometry then. Let's work out what the sine, first of all, of 45 is. Well, from trigonometry, sine is opposite over hypotenuse. Well, let's go with this angle here. Opposite over hypotenuse is 1 over root 2. That's what we call the exact value of sine 45. Obviously, this could be simplified, but we don't look at surds or simplifying surds in maths methods. Let's look at cos 45. Cos 45 in this case is the adjacent divided by the hypotenuse. Adjacent divided by the hypotenuse is also 1 over root 2. Tan 45. Tan 45 is opposite over adjacent. 1 over 1, which is 1. So we can say that tan 45 is 1. Let's look at a second special triangle which has other angles in it, such as the equilateral triangle. I need to create a little bit of space. Alright, so here's my equilateral triangle here. Now an equilateral triangle has properties where each angle inside the triangle is 60 degrees, making it equal. And all three sides have to be the same. Now I can't perform trig on this kind of triangle, so I need to cut it in half. So cutting it in half means I get the distance across one of the sides halved. Now really I want to be using whole numbers, so if I make this distance here 1, this would be 1. That means that the whole of these equilateral triangles have a length of 2 all the way along. So let's just focus on this small part of the right angle here. Cutting this angle in half produces an angle of 30 degrees. That enables us to work out exact trig values for both 60 degrees and for 30 degrees. So let me just put 30 degrees there, and let's just take that off. So I'm just focusing now on this right angle triangle. Let's go with 30 degrees first. So that defines this as the opposite side. So when we do sine 30, let's write sine 30 here. Sine 30 is the opposite, 1 over the hypotenuse 2. Sine 30 is exact value is a half. Cos 30, cos is adjacent divided by the hypotenuse. So the adjacent, of course, is this. We haven't worked that out, so we need to use Pythagoras' theorem, which says 2 squared subtract 1 squared gives me root 3. So the height here is root 3. So performing adjacent is root 3 over the hypotenuse 2. So cos 30 is root 3 over 2. Let's have a look now at tan 30. Tan 30 is opposite over adjacent, 1 over root 3. Now let's consider the 60 degree angle. Sine 60. Well, sine 60 opposite, so our opposite now becomes root 3 over the hypotenuse 2. So sine 60's exact value is root 3 over 2. Cos 60. Cos adjacent, well the adjacent is 1 and the hypotenuse is 2. So adjacent divided by hypotenuse tells us that the exact value of cos 60 is 1/2. And then tan 60, well, tan 60 is opposite over the adjacent. So it's root 3 over 1, which is just root 3. So the exact value of tan 60 is root 3. And that's pretty much everything you need to know about these special triangles and how we can work out some exact values. Don't forget, other exact values are those boundary angles. So we can work out sine of 0, cos of 0, tan of 0. We can do 90 degrees, we can do 180 degrees, we can do 270 degrees, and so on. Don't forget, these can also be transferred into radians. To transfer, we've got pi upon 6, so we would say that sine of pi upon 6 is also a half. Cos of pi upon 6 is root 3 upon 2. Similarly over here, 60 degrees is equivalent to pi upon 3. So sine pi upon 3 is also root 3 over 2. Cos pi upon 3 is also a half, and so on. Let's talk about 45 degrees. 45 degrees is equivalent to pi upon 4. And we learnt on the previous slide, call it a slide, that tan 45 was 1. That means that tan of pi upon 4 is also 1. And that's pretty much everything you need to know about angles between 0 and 90 degrees. You'll have to watch a second video for angles above 90 or below 0.